Hello, everyone, and welcome back to your channel or your series of probability and statistics. Today, I'm going to go over how to plot several plots on RStudio. I already have a file open just to show you what it has. As usual, the environment is clean, but we always prefer to make sure we clean it before we start any new problem, just in case we have something saved from the previous problem. So what we have here is we have a text file. It's called example 715 from one textbook that I used in one of the lectures. And this file contains 17 data points just listed. We don't know what these are. They are sorted. I don't care if they are sorted or not. We can easily sort them with RStudio, but that's not our job now. Our job is we want to see how I can plot several plots on the same screen. Okay, so first I'm going to start reading the file and save it to a variable. I'm going to call it my file, for example, uh, equals, and this is a text file. So I'm going to say read.table. And you see here when you do a table with the name of the file, it assumes there is no header, which is our case. So we don't need to write true or false or anything. Just leave it. Had this been a CSV file, you see header equals true. That's why you always have to be careful what type of file you are opening and what is the default for the header. Because here, if I leave it as it is, it will call the first, this number, it would call it the header. So it's like, oh, you have a column or a vector named 1470 or dot 1470, which doesn't make any sense, right? I don't have headers. So you have to be careful. If that had been a CSV file, you had, after entering the name of the file, to say comma false or comma F or comma header equals F. Okay? But we don't have that. We have a table and the default is header is false. So what happened? Read table, and I'm gonna enter the example, this exactly the same way it's written, underscore 7 dash 15 dot text. Okay, that's all in this case because tables assumes you don't have a header. But so what, how can I refer to this column if it doesn't have a header? Yes, when you attach it, it's going to give it a name. So when you open my file, which is a copy of example 715, you're no longer dealing with example 715. When I say attach my file, it's going to make a copy of that. It's going to make a copy of this example and name this column because it doesn't have a name. So it's going to call it V1, uppercase V1. Okay? And that's it. So once you attach it, now you can plot the histogram, you can plot a box plot, you can plot a QQ norm, QQ line to see how it fits with the normal distribution, if any. You can do whatever you want. However, to open the screen to show, instead of going to plots here and see the plot small and then you enlarge it or you zoom it or you copy it, no, you want the screen to show you the everything, okay? So if you are using a Windows system, you simply type Windows, that's all, nothing else. It will open you a clean slide, okay? However, I'm not using Windows, so I'm not allowed to type Windows on a Mac. I will be doomed, right? So if you are using a Mac like myself, use Quartz. So we don't like to use Windows, we are going to use Quartz. It's funny, but that's the truth of the thing. If we say Windows, you get error. If you use Quartz on Windows, they know you are like a spy, so they will cancel your system. Anyway, Now I have a clean slat. I want to divide it into four pieces because I'm going to plot four things. I will talk to you about these. And I want them two rows and two columns. It will start with the top left, then top right, then bottom left, then bottom right. And the way to do it, we did this before. We use the keyword par. Okay, that's how you are going to divide your plotting area. And you say MF row equals C. Usually we use C to combine everything. And then you enter how much do you want at the bottom first. B is the first letter in bottom left, top and right, right? B is the first. So it's you enter the bottom, then the left, you go clockwise, then the top, then the right. Bottom left, top right. Usually we start with 2, 2, 2, 2, so it really doesn't matter which is which, okay? But so that's how we. Okay, I'm sorry. I was ahead of myself. Sorry, 2 and 2, meaning you have two rows and two columns. I was talking about the margins because once we were plotting something and it says margins too narrow. So you have to do the margins. Please accept my apologies. MF row just tells you you want to divide the slat in how many rows and how many columns, but margin, it tells you how wide you want your margins to be. And as I said, we start with 2, 2, 2, 2, and then if we want to increase something, we can go back and change it later. Okay, so what do I want? I want to plot a histogram, hist of V1. That's it. Maybe you want to have a header for that, meaning a title. I'm not going to say header because we don't have headers. Okay, so I want a title. The keyword for a title is main. So I say main equals, and then I say histogram. I don't know what this data is for or whatever. So histogram of data or just histogram. That's enough. I can have a label for the x-axis. So I can say xlab for a label equals data, and maybe a y lab equals frequency, frec. And then I want the histogram to be yellow. That's it. Then I want to do a box plot. A box plot also of V1. So the title for that, male, not male, box plot. I'm not going to use xlab or ylab. This is easy. I want to do the color equals red. Oh, RStudio, when it plots the box plot, it always plots it vertically, which most people are not used to, okay? Because it gives you the lower quartile, then the median, then the upper quartile, and if we have any outliers or the minimum and max. So if you want it horizontal, you have to say horizontal equals true. Because here it plots it vertically. At the end, we can say QQ norm of V1. And then on the same line, you want to add QQ lines also of V1. So these are three. Can we add a fourth one? Let's say without my file open or anything, I'm going to say, I'm going to plot the standard normal distribution. So I'm going to say X is a sequence. I know that pretty much all the distribution is between -3 and 3, right? But of course, if I leave it like that, it will gets it like at -3 and then at -2. No, I want that with point, maybe that, okay? So it will make like 7,000 or 7,001 calculations of y. And y here is the density of the normal function of x. That's it. So I'm going to plot x versus y. That's the last one. I want it at the bottom right. So plot x and y. Again, you can add mean equals uh, standard normal distribution. Uh, I want the type to be L because usually the default is O. It will draw 7,000 or 70,000 O's next to each other. Yes, it's gonna look like a very thick normal distribution. But if you wanted just a line, you say L. So the default is O. And I think that's it. It's usually a good practice that at the end you return the slat to be only one big clean slat. It's not divided into four, so you can say par mf row equals C of 1 and 1. I hope we don't have any typos here. Oh, we didn't do a color, so let's do color equals cyan. See? Oops, it didn't plot. Wait. Why didn't it plot? Why didn't it plot the standard normal distribution? That doesn't make sense. Oh, did I close it? Oops. Error in QQ lines. QQ line, not lines. Okay, let's see. Now you have to close this to see it. Yeah. Okay, so that's the histogram. Here we see that we have a long left tail, so it's negatively skewed because the median is not in the middle. We have larger distance between the lower quartile or the first quartile and the median than the median and the top quartile. Even this leg is longer than that, so this data is negatively skewed. And you can see it from here. So this tail is more than that. Data point you see at the bottom, there is quite a few points away from the line as well as the top, but usually the top and the bottom. But you can see that it's not really quite normal. And here's the normal distribution graph. And you see the maximum is slightly below 0.4, roughly 0.4. Okay, that's important to know, but that's it. Oh, now one quick thing. Suppose I want to, oh, what's going on? Oh, I have to show this. Suppose I no longer to show that, so let me clean the slat. And I'm not going to open the file or anything. Okay, let's delete these 3 lines. I want to show a comparison between the T and the Z. Remember, the T looks exactly like the Z, but I told you its top point is lower and its Q's, right and left tails, are thicker. So let's do this. Let's say if this is Y, I'm going to say Y1 equals dt of X and maybe 4 degrees of freedom, meaning I have a sample of size 10. And then I have Y2 equals dt of X and 9 degrees of freedom if I have a sample of size 10. And finally, I can do Y3 is dt of X and maybe 29 degrees of freedom. So 30, 5, 10, and 30. Notice, remember, I prefer to say n1 equals 5, n2 equals 10, n3 equals 30, and then here say n minus 1 in all of them, but it doesn't matter. Okay, so if I say plot and copy and paste this line 4 times, it will give me 4 different plots. And if I do that, I cannot compare them because each one has its own scale. Each one has, so they may look exactly the same to me. I want to combine them all into one plot and show all four on that plot. How do I do that in RStudio? That's that's important to know. And the way you do it is that after you are done with this line, you go to the next line, and instead of saying plot, you say lines. And probably that's why I said QQ lines, because I have in my mind that I will do this problem. It's QQ line only, it's only one line. But here you would say lines X and Y1. That's it. And then lines X and Y2, X and Y2, and then lines X and Y3. Of course, I cannot show how do I know which is which? So maybe I use colors. Color equals green. Green for the first one. And color equals, say, brown for the second one. And have color equals blue, magenta for the third one. The only problem is because I'm not sure if it will show the whole graph. Let's look at that. Most likely it won't. So if I plot that, that's what I get. Oh, no, it shows, that's fine. So you can see that the top line is the normal distribution. Then the T with 4 degrees of freedom, then 9. Oh, I'm sorry, 4 degrees of freedom is the bottom. 9 is the second one. 29 is very close to the normal distribution. That's why we say when we have a sample of size 30, we can use the Z. You see, they are not exactly the same. That's why I prefer to use the T always, since I do it with a calculator. I don't need to try to find it myself, which is so horrible, right? We no longer look into tables. So you see, there is it's a small difference, but it's a difference nevertheless. So that's why in all cases, I prefer to use the T. If I make the degrees of freedom like 999, then you cannot discern any difference between them. But uh, even if I have large samples, the T is better than the Z. It's more accurate. By the way, sometimes when you plot these, you get part of the graph is truncated. I told you that the highest point, I closed it. The highest point is 0.4. So you can add that in the plot function. You can anywhere come here. Let's say we come here and you can see it. You can say xlim. I don't care about the x. The x, we said it's going from -3 to 3, but it's very wide. But I can say ylim equals c. What is the minimum? 0, of course, because you don't have a negative uh, part. And 0.4. So you make sure it covers up to 0.4, so nothing will be truncated. If you see something truncated, you can set the limit. Okay? And that's what you will get. So you see it goes up to 0.4. If you wanted to go higher, of course you can. If you don't, sometimes it stops somewhere here and truncates it and you don't see the top part. Again, it's just you can set the limit, you can set the label like we saw. So you can set the main, you can say xlab for label equals data, y label is frequency or distribute density function, probability, whatever you want to type. Okay, will show up here. I think that's it for today. I hope it wasn't that bad. And we can stop here and probably see you next time. Thanks for your time. Have a great day. Bye.